All right, now we're going to tackle probably the most difficult ones, which are the glide reflections. So the thing is that glide reflections, while you think of them as being this kind of simple glide and reflect, they can look like a lot of different things. So it turns out that if you reflect something and then you translate it and then you rotate it and then you translate it some more, wherever you get to is gonna be a glide reflection, unless it's a simple reflection, of course. So your glide would be a zero vector. And so this is kind of hard to visualize. And in fact, I got this glide reflection version of my starting out shape by doing something that wasn't, a simple reflect along this line and then find a vector in the same direction, right? So I made this a different way. I don't know where the glide reflection vector is, but we're going to find it. Now, in order to find this, we need to think about this fact about a glide reflection. So I'm going to put a glide reflection on here for us to think about. So it's going to have a reflection line, and it's going to have a glide arrow, a glide vector, and the vector is going to lie in the reflection line. We could have it parallel, but any parallel vector tells you the same translation. So I'm just going to put it in the line. And now I'm just going to put a point on, and we're going to look at what happens to that point. I'm going to make this glide vector a little shorter. All right, so I'm going to take that point, and I'm going to reflect it. And then I'm going to translate it. And now I have the beginning and the ending. And we're going to connect those up with a line to see if that will help us understand anything. So here's a segment that goes between the beginning point and the ending point. And so that it should not be at any surprise that that line is going to intersect the reflection. All right. So, of course, that's going to intersect somewhere. Let's put that point at the intersection. Now, if I had, instead of this glide reflection segment, if I just had a reflection segment, then you would know what would happen, I think. I hope. I hope you can visualize and think, oh, if I have a point and its reflection, then it's going to be equidistant. That's part of my definition of a reflection. Equal distance from that reflection line. And so this intersection point would be the midpoint of that line. And that same thing is going to be true if I take this point and I translate it parallel to the line. This point, this point that intersects the reflection line, is still going to be the midpoint of that segment. Let's test that by measuring. So I'm going to measure the distance from L to M and the distance from M to L double prime, and those come out to be the same. So that's the midpoint. So what's going to happen if I look at the midpoints of the segments that go between the before and after points? They should all lie somewhere on the reflection line. So this isn't going to get me my vector yet, but it is going to get me my reflection line. So I'm going to draw some segments. Here's my segment tool. I'm going to draw the segment from A to its image. And how about C to its image? You want to have segments that are far enough apart that you're going to be able to distinguish those midpoints. I could put some more in there too, but I don't have to. And now I want to find the midpoints. All right, so midpoint is under construction. Here I construct a midpoint or a center. So if I choose this tool and I just click on that segment that I've already drawn, then that will give me the midpoint or the center of that segment. There's the center, there's the center. And those should look like they are all on a line together. They are. They are on the reflection line. I can pick any of two of those points to connect up and say, that's my reflection line. Okay, so that's like half there. I have my reflection line. Let's find the vector. So to find the vector, the thing that I'm going to do is I'm going to think about, okay, the first step of a glide reflection could be the glide, or it could be the reflection. That's, I hope, what you discovered when you experimented with gliding first and then reflecting, or reflecting first and then gliding, is that if they have to be in the same direction or in the same line, then you get the same thing, no matter which order you do it in. If the vector doesn't go along the line, then you don't get the same thing from the different orders. So what I'm going to do is I'm going to pick one of these points, or I could pick the whole thing, and I'm going to reflect it in this line. So I'm looking for my reflection. Reflect about line. Check. I'm going to go ahead and reflect the whole shape across the line. Okay, there we go. This would be okay if I even just used this point A, because what I'm going to use to get my vector is I'm just going to use any one of these points and its image. And if I do that, let me find my thing that lets me draw vectors. That vector is going to be parallel to the reflection line. And all of these vectors are going to tell me that same translation to go from this version to that version. So that is a way that I can use midpoints to find a reflection line. And once I've got a reflection line, I can reflect one point, any point you want, and use it to get a vector.